In this video, I want to talk about how to find the outstanding balance on a loan, and I'm also going to talk a little bit about amortization schedules. The outstanding balance of a loan is simply how much is left. Here, we want to find the present value P, or PV, for all future payments that haven't been paid yet. Here, T in our formula doesn't represent the entire term. Rather, it represents how long is left, what time remains on the loan. And M times T represents the total number of future payments. So when we use TVM solver, N, which is always M times T, will be future payments. For example, Mr. Jackson bought his house in 1995 and financed the loan for 30 years at an interest rate of 7.8%. His monthly payment was $1,260. So he got a 30-year mortgage for a house. His monthly payment, $1,260. In 2015, he decides to pay off the loan. So 20 years after getting the mortgage, he's made payments for 20 years on his 30-year mortgage. He is going to pay off the loan. What amount must he repay? T is 10 here, not 30. That's probably the most common mistake people make. It's 10 because there are 10 years remaining. There are 10 years left on the loan. So T is 10 because there are 10 years remaining. N in the calculator, or MT, is going to be 120. 12 monthly payments times 10 years. We'll use the formula to find the present value of an annuity, which is P, or PV, equals the payment times this lovely plethora of symbols. When we plug in our values and we do all of this, we get $104,761.48. Remember that this part here, this is to the negative 120. We aren't subtracting 120. We're raising this in parentheses to the negative 120. Please note, this is not the same as making 120 more payments of 1,260. That would be actually way more. Whenever you can pay a mortgage or a car loan or another loan off early, you save a lot of money because you're not paying interest on that amount. The calculator is going to be a much quicker way of using it. We're going to go to TVM solver. So our N again is 12 times 10. You can just put in 12 times 10. It will calculate 120 for you. I percent, that's the interest rate as a percent. Notice here we have the little square by PV. That means this is what we're going to solve for. So that when you first do this, it doesn't matter what number is here. You can put a 0 there, or you can leave whatever value it already has. PMT is our payment. We're going to put a negative sign in front of it because it's what we're paying out of pocket each month. We're not interested in future value here, and we're making 12 payments a year. So I enter in these values, and then on the calculator, using the cursor keys, I'm going to go up to PV, and I'm going to hit the alpha key, and then enter. And that is going to give me my answer, $104,761.34. Notice this answer, which we would include, of course, a dollar sign and all that good stuff for if we were writing it out, is going to often be a few cents different than it is if we use our formula. So here on the calculator, we got $104,761.34. In our formula, instead of 34 cents, we got 48 cents. That just has to do with how much rounding we do in intermediate steps. So the calculator response is, when you use TVM solver, is going to be more exact, more precise. That's okay. That's a good thing, in fact. Finally, the amortization schedule for a loan. The amortization of a loan simply is how long it takes to pay a loan off. So if you get a 30-year mortgage, if you don't pay it off early, it will take you 30 years to pay off that loan. If you get a car loan for 5 years, it will take you 5 years to pay it off. The amortization schedule of a loan is a table that lists all payments of the loan. So it's monthly payments for 10 years, you'll see 120 payments. If it's monthly payments for 30 years, you'll see 360 payments, and so on. It splits each payment into the amount that's devoted to interest and the amount that's devoted towards the principal of the loan. And then it calculates how much is left on the loan. That's the outstanding balance after each payment. And what you see here is a template from Word. And notice how that it has a column that is for the principal and a column that is for the interest. So this particular loan, each month they're paying about $607. And each month, different amounts of that go towards the principal of the loan and the interest of the loan. The interest goes down a little bit each time because you're paying off more of the loan each time. So that first month's interest is going to be the greatest because there you're paying interest on $100,000. But the second month, you've paid off about $230 of that. So you're paying interest on about $99,770. So your interest goes down a little bit. Amortization schedules today are always done via software in something like Excel using this template. I don't see a benefit in doing them by hand for our purposes in this course as an introductory finite math course. Sometimes finite math does have them do them, and that's fine. I just think we're not going to. So you are not responsible for completing an amortization schedule for this course, but I want you to be aware of what it is. And so this is what it looks like. So if you ever hear or read about or see an amortization schedule, it's just a list of payments, and specifically the payments are broken down and how much each payment is spent on the principal or is paid towards the principal of the loan, and how much in each payment is paid towards the interest of each loan. So I hope that helps. If you have any specific questions or I can help more, please let me know. Good luck moving forward.